Alright, so let's go ahead and talk about our first Linux laboratory. And what we're going to do is I'm actually going to be going through this with you on this online video lecture. Now, one of the reasons I'm doing this is I get asked multiple times by many of my students, hey, I think I understand all of this, but when I go home and I practice this in NetLab or I'm practicing this on my own virtual machine, I get kind of tripped up and I forget where I'm at, I forget what I'm doing, or maybe something you said in lab triggered with me, but now I've forgotten it, right? So because of all of those things, what I want to do for you guys is go through this lab with you in a video tutorial so that I can go through all of it just as if I'm in here in lab with you in our laboratory. And so that's what we're going to do in this three-part set of labs, and we may extend this beyond three, but initially it'll be three. So here is lab 2 that I've got ready for you right here, as you see. Now, one of the things about this, keep in mind, lab 1 was our install of CentOS, and so I don't actually have a lab that I'm going to go through with you in the CentOS install here, but I will have a video lecture up that does cover a CentOS install in case you'd like to do that again. But keep in mind what we're going to be doing here is specifically starting at Lab 2. And so with Lab 2, I kind of want to get you familiar with Linux. I want to get you familiar with the operating system, how it works. You're going to see some similarities to Windows, but then you'll also see, of course, some very foreign concepts that if you've only worked in Windows before, the Linux will seem really kind of different. And it's like that, for example, if you've ever tried to learn a new language. There are nuances and syntaxes and different things that make learning one language very difficult because of the new concepts that may be given to you. And it takes a while for your brain to wrap its mind around it, so to speak. It takes a while to kind of grasp those concepts. And so that's really the goal of what we're trying to do here in this lab. So let's go ahead and get started. One of the things we're going to be looking at explicitly is looking at terminals. We really want to have a good feel for terminals. Now in lecture we kind of discussed the Linux terminal, where it came from, how as Linux kind of came out of the Unix and open source movement as a combination of those two things, that because of mainframes being so popular, this idea of a terminal was quite common in the Linux and Unix world and has really been carried over in a modern way, in a very sophisticated modern way today. And so we see terminals all the time, and so it should be something that you get used to and you're familiar with. Now, if you look here, technically I am in a terminal. I'm in TTY1 right now, and so it is possible that within this Linux system right here that I can have the ability to switch to a different terminal. And so I'm currently in a graphics terminal. Now it's actually been a while since I've done this in a virtual machine, so I'm going to go ahead and see if I can switch this over to a different terminal. I know the keystrokes do exist. Ah, there it worked. First try. Sometimes you get lucky. Well, maybe not. Didn't seem to take it. There it goes. Okay, so I just switched over to a new terminal. See this right here? So what I've done is I've switched over to TTY2. Now in lab, what you do with your keyboard is, as you see right over here, my mouse is now no longer available. Let me Alt-Tab over. We normally do Control-Alt F2, F3, F4, F5, anything from Control-Alt F1, which Control-Alt F1 is your graphics. Control-Alt F2, F3, F4, F5, F6 are the TTYs or the teleterminals we have available to switch to, and all of them except for the first one are non-graphics implementations. They do not have graphics with them. They're running text only. And so I'm going to go ahead and log into this guy. Let me click over on him again. Every time I click I lose my mouse control since it's non-graphics. So I've now logged into this system, alright? So I am currently logged into this Linux box, currently in TTY1 because you saw I was already logged in, and then I press Control-Alt F2 to switch over to TTY2. And so I am actually on the same system, but I'm logged in twice. So the lab, as you see here, talks about running the who command, and one of the reasons you can do this is it will tell you who is currently logged into the system, alright? So if I run who, look what it's going to tell me. It tells me that I am currently logged in into TTY2, which is correct. That's where I'm currently logged in from at this point in time. Now I can also use the W command, and look at what the difference is here. With the W command, it gives me a little bit more information. You see this here, and so I can see that I'm logged in from TTY2 just like the other one. It has a timestamp, but it also shows you the login time, idle JCPU, and PCPU times which are not important for this class. And so this actually gives you just a little bit more information about what your users may be doing. And there's of course a lot of let's see, a lot of other options you can give with it. Some that give you less information, some that give you more information. So anyways, just wanted to show that to you so that you can be aware of maybe what TTY you're in, who may be logged into your system at this current point in time. Those kinds of things can give you some more information. Alright, so now in the lab it says to go ahead and switch over to TTY3 by hitting Control-Alt F3. So I'm going to go ahead and switch over to TTY3, and notice it looks somewhat the same, right? Now I haven't logged into this terminal, so every time you switch to a new terminal, you've got to log in again. So this time I'm going to log in with a different account just so there's a difference here. So now look, I've done TTY2 and TTY3. So if you look here at TTY3, I'm logged in as Wes. You see that right there with Wes at localhost. If I go back to 2, Control-Alt F2, you still see my old screen. So what this should tell you is that each terminal is currently running, and each terminal is storing for you all the information that you have run previously. You can switch back and forth to them. They're on the same system, they're multitasking between each other, and they allow simultaneous logins. So let's go ahead and go back to 3, and I'm going to run the W command again, and now look what it's done. Now it has shown me that Wes is also logged into TTY3, the user Wes. And then you can see some of the same information, when he came in, idle time, etc., etc. Okay, so this actually shows you some more information about what's going on the system, and can show you if you do have multiple TTYs, multiple people accessing the box, you know, what TTYs are in. And this gets even more important when you may have people remote shelling into the system, where you have people that are connecting via SSH into this system. And so that's where it can actually get more important. So you can actually switch between the other TTYs. Here's TTY F4, F5, F6. You kind of get the idea here. And then now we're back to TTY. There we go. TTY. I'm hitting too many buttons here. There we are. Back to my TTY1. Okay. So I'm going to go ahead and log back into that so you can kind of see how all this works. I can switch from one to another to another. Let's go back to TTY-F2. I always tell my students I want you to get used to using. There we are. I want my students to get used to using the non-graphics. I want you to get used to text mode only, because that's really where you become more familiar with the system. All right. So anyways, let's go ahead and move on a little bit down past all of this. Now we're getting here. I show you how you can actually connect to a computer. I think I can get this going if I open up another virtual machine. Let me see if I can do that real quick. And what you're going to notice at this point, this is where you're going to see that this will differ somewhat from what you're doing in lab, because you're going to see some different IP addresses and some differences that really are pretty significant. So hopefully this part I'm about to get into will make a little bit more sense. Let me go ahead and do the lab talks about doing an IF config. Sorry, in Windows it's an IP config. In Linux it's an IF config. So I'm going to run IF config, and you can see right here my address on this box is 192.168.251.131. If you don't see that, hit pause on the video until you find it. Now notice this is what I was talking about a second ago. These IP addresses that I have on my virtual machine are different than what you're using in lab, and maybe even different than what you're using in NetLab or possibly your own virtual machine at home. So don't let those IP addresses trip you up. Don't let those kind of get you confused, so to speak. I'm going to go ahead and switch back to my graphics here and log back into this guy. Okay, so what I've done, sorry for the screens kind of flipping back and forth. I've got another machine coming up here for you to see. Okay, so I now have a second machine that's on here that I brought up. So these are actually two different Linux machines. Even though they're both virtualized, they are two individual machines. Just like when we had in lab, you had a partner using their computer doing operations and tasks on that machine. And so I want you to be used to that. For some reason, though, it is not responding here. Let's see if I can get to another TTY. Okay, so if I look on this machine, I'm going to do an IF config again, and notice that it is a little bit different than this machine right here. If we look here, this machine's IP addresses we talked about is 192.168.251.131, whereas this one here is 192.168.251.133. So they should be able to talk to each other. And I'm going to go ahead and confirm this. I'm going to ping 192.168.251.133, which is this guy's IP address, okay, this machine over here. So I'm going to see if I can ping him, and I can. Look at this. I get four returns back, or actually continuous returns that come back here that say, yeah, this worked. You actually were able to connect to it. So I can confirm that these two guys can talk to each other because this guy can ping him, okay? So what you're going to do next in the lab is you're going to look at how I can connect from this computer to this computer, or vice versa, through a protocol called SSH, or Secure Shell, which allows me to securely connect and have a pipe, so to speak, from one computer to another, where you can send and receive information, basically sending commands. So you're administrating it remotely. Okay. So a couple things the lab has you do just to get started. And I know in the real world we don't want to disable our firewall. We need to write a rule to pass it through. But this is not a firewalling class. You'd have to take my other class if you want to look at firewalling and how that works. So for now, we're just going to do a service IP tables stop. Okay. So what that's going to do is it's going to turn the firewall off over here. Now we need to turn it off over here as well. So we're going to do a service IP tables stop. So now both of these machines have their firewall turned off, and this is very important so that we can get this SSH to work. Another thing that we need to do is we need to turn on our SSH service, and I actually believe they're already set up, but just in case they're not, I want to make sure that we get this right here. Where did my other? There it goes. It's hiding from me. Okay. So let's go ahead and do a service SSHD start on this machine. So now we have done what the lab has asked us to. We have stopped our firewall and we've started SSH. Okay, so now we should be able to connect to each other. Okay, so this is the part in lab where we actually tried to do that. So here's what we're going to do. From this machine over here, I am going to see if I can connect to him. So SSH, and then I provide his IP address. Okay, so it's going to be 192.168.251.131. Okay, that's the other guy's computer. That is his computer right here. That's his IP address. So in other words, I'm connecting from this guy to this guy, okay, over a secure shell. So I'm going to go ahead and connect. It gives me an RSA key print that I need to look at, or fingerprint, I'm sorry, I need to look at. And again, in the real world, we probably want to confirm that this is correct. Assuming it is correct, then I know who I'm connecting to, and I should be able to connect to this machine. And sure enough, I do. Now, here's where this can get a little tricky for you, all right? At this point, it looks like, if I send commands, it looks like I'm still on my same machine, right? It looks like I haven't done anything different, right? One of the reasons for this is that this machine is named localhost, and this machine is named localhost. But if these actually had different machine names, and I probably should have done that for you setting this video up, then you would actually see that this would change from his name to this person, to this machine's name, okay? But here's another way that we can actually confirm that we're logged into another machine, okay? On this, so keep in mind, this guy here is actually connected to, via SSH, connected to this machine. And let's confirm this. Okay, remember the W command or the who command we were just running? Watch this. I run it again, and look what it shows. It shows that root is logged in through sudo terminal 1 from this IP address. Now, what IP address is that? Well, remember over here, if we were to scroll up, I don't actually have a page up on this keyboard, silly Mac. Anyways, you would see that this one is 192.168.251.133. You would actually see that. So because he is connected to him, if on this computer I run and say who's connected to me, we actually see that he's connected to me. All right. So we can actually see the connection source, and this is very important because now we know who is connected to this computer. In Linux, this is very common. People are connecting all the time. For example, on my web servers that I have access to, I'm connecting to them, and other people are connecting to them quite often. And so as an administrator, you need to know who's connected and where they're connected from to be able to troubleshoot any kinds of problems. Okay. So now on this guy, I'm going to go ahead and exit out of this session. And notice it says that connection was closed, okay? And normally, again, if you were to have, these guys had different machine names, this would change from, you know, whatever it was to whatever this guy's name was all over again. So that'd be another way to know. We can confirm over here by typing the W command again, and look, it's clear. See this? So now we can confirm that he is not on our system anymore, okay? So that's kind of what the lab walks you through with SSH, how you can remotely connect from one person to another, and that's pretty important to be aware of. We can do some other things looking at what version of Bash we're using. We've talked about Bash quite a bit, or at least somewhat in lecture time. We talked about the fact that it is our shell, which essentially is what allows us to send commands to be interpreted by the kernel to accomplish the system task, whether it's pinging, whether it's SSH, whether it's opening a web browser, whatever it is that I need to be able to do. Bash is what helps me do that. It is a shell or an interface between me and the kernel to send commands to it. So if I type bash -- version, it tells me what version of Bash I'm using, shows that it's released under GPL, so on and so forth. Okay, so that's what that'll talk about there in the lab. Now what we're going to do is we're going to get used to handling, just getting used to the system a little bit more. Okay. So right here in the lab, it talks about the fact that it says, if you look here, it shows that we're root at this machine name, and then it also gives you the directory you're in. See this right here? So for me, this computer is called localhost. Now again, if I were to change that name from localhost to something else, you would see it. But currently this machine's name is localhost, whereas in lab, our machines are all, you know, IT 225 and then a letter, right? So you should remember this. So one of the things that we need to do is get used to understanding this. This first section right here is the user. This right here is the machine name, and this right here is the directory that we're in. Now that doesn't show the full path. It just shows the actual directory I'm in. So for example, if I go into Etsy init.d, it now shows that I'm in init.d, but it doesn't show the full path. See that? It doesn't show /Etsy/init.d. It just shows init.d. So you need to keep that in mind. But it does show who I'm logged in as and what machine. So if I were to switch to root, for example, watch what it would do. Now notice it switches from earlier I was logged in as Wes, now I'm logged in as root. So pretty useful stuff. Also notice that it switched my directory. See, I was in init.d, and now it switched me over to my home directory. Remember that tilde is actually the user's home directory. Okay. One of the things that the lab does is it talks about the pwd command. Now that's not the password command, it's the print working directory command. So if I forget where I'm at, I can type pwd and it tells me, oh, you're in /root. Or if I go back to my Wes account, pwd, oh, you're in Etsy init.d. See how that works? So you need to get real used to seeing that, because you could always be in some random directory, like this, for example. Like, where is that? I don't even know the full path. Well, pwd, 3 quick letters and hit enter, and it tells you exactly where you're at. So it needs pwd needs to be a command that you're very, very used to. Another thing that we can do is we can list directories. Now this is very, very helpful. Let's say I need to see what's inside this directory. I'm currently in temp VMware config 0, and I want to see what's in it. We'll type ls, and it shows you what's in it. See how this works? Now that one's not real useful because there's not much in there, but what about this? There's a lot of stuff in Etsy. See all the stuff that's in here? So what the ls command does is it shows you everything that's in there. Now, as you're going to see later, there's a lot of things that we can do with the ls command. We don't just, we can't, it's beyond just running ls. You can do other things like ls-l Etsy. And it shows me the same stuff, but it gives me more information that we'll talk about later. Okay. Same thing with ls-a Etsy. And now instead of just showing regular file or showing, you know, a regular listing, we also see hidden files, which there aren't a lot of these. There's a few of them. So there's all kinds of extra options that you can add with a lot of programs in Linux. And you don't have to memorize them all. Some will just come naturally by using them, and becomes almost muscle memory, so to speak. And then others you'll just have to use the man pages, which we'll talk about in just a little bit. Okay. Another thing I can do is I can specify, if I just type in ls, it lists what's in my current directory, which for me right now is Etsy. See that? But I can also list and see what's in a different directory. See this? I can do an ls temp, and if I'm not in that directory but I specify where it is, I can list it. So this can be very helpful for you as well. If you don't want to have to go, oh, well, let me cd and change the directory over to temp and then do an ls, you can actually just do an ls temp or an ls home Wes, you know, all kinds of stuff. All right, see how that works? So pretty useful. Now, just a second ago, I talked about the man page, right? What if you forget what the option is, right? Well, this is where the man page can become useful. I say, well, I forget all the options I have with ls. Well, you can type, well, I did that too quick. The man command is for manual, okay? So I can use that. I can do, for example, man ls, and look what it does. it shows me all of the different options that exist with LS, probably more than you expected, right? And again, this is why the man pages are very common, because nobody expects you to have all these memorized. That's where the man pages become useful, and you can look through those for specifically what you're looking for, and then use the option as you see fit. Okay, so that's what all that's for. The lab walks you through some more information here on the man pages stuff, or man page information, which is really useful, but for brevity's sake, I'm going to go ahead and move on past that. We also have the info command. I'm going to move past that as well. Okay, so here's some other information, changing directories. I've already actually been doing some of that for you in this video lecture. Most of you are pretty familiar with this now. But notice we can do some other things, all right? So here in the lab, it says normally when you log in as a user, you end up in the user's home directory. So this little tilde, it's the button right next to the 1 command on most keyboards, except you have to use the shift. Okay, it's that little squiggly dash. That is actually a variable for the home directory of the current user. So if I do a cd space tilde as the Wes user, and then I type, notice that it changes me to the tilde directory. Okay, now that is not a directory itself, it's a shorthand. So if I type pwd, notice it says home Wes. See this right here? Now I don't know if I have any other users on the system. Let me look. I think there may be, well, root will work actually. Let's just switch to root, okay? So now I've switched to root, all right? It says that it's tilde as well. So when I'm logged in as Wes right here with tilde, it said my home directory is home Wes. So is root's home directory here, if it's tilde, is that home Wes as well? Well, you should know by now, no, right? Tilde is each current user's directory, home directory. So for root, look where it is. It's /root. So all home users by default in CentOS, their home directories are /home and then their username. So home Wes, home user 1, home user 2, etc. Whereas root, he has his own directory and is in a private area in /root. Okay, everybody else is in /home something else, but root is in /root. So he's in his own area. He does not play well with others, right? All right, so we're going back to Wes. All right, a couple more things here. Here's an example. We changed directories, and I've done a little bit of this for you, but I'm going to go ahead and do this as well. So here we're in yum repos. Not important to know what this is for, but if you type a pwd, notice it shows you the full path and where you're at. And then we can type in the cd command, the cd tilde, or even just cd, and notice it brings me back to my home directory, and now I'm back to home Wes. Okay, so that's how that can work. Also, one of the neat things is we do have a couple other users in here. Okay, so another thing that I can do is, instead of specifying, let's say I am in that that long directory. Why am I not getting? Oh, it's a yum repos. Yum.repos.d. There we go. Okay, so let's say I'm in this directory. All right, and let's say I want to switch over to the snort directory. Okay, the user snort. Okay, watch what I can do. I could do cd space /home snort. Okay, but since I know, actually this is not going to work. Sorry. Let's say I need to switch over to a subdirectory under Wes. Okay, and that, let's say that it's the desktop directory, which I know is there. Watch what I can do. I could do cd space home Wes desktop. Okay, and that would work. But what I could do to be even quicker is this, and that is home Wes, right? Because we already showed that /desktop. So all that does is it saves you some typing. But when you get used to those shortcuts, for example, that tilde is /home in the current user, in my case /home Wes, those kinds of things will save you a lot of time as you begin to go through Linux. And that's where it can really become very helpful, as you begin to put lots and lots of shorthand things together, and you can really go quickly through through Linux as you begin to get familiar with it. Okay. Now what we do is cd/. This takes me to the very top level of our Linux directory. You do an ls, here are all our top level directories. Okay, so that's what this is walking you through. Now we look at a couple other things. I talked about the ls-l a little bit. If we do an ls-l, notice that it shows each of the same directories it showed as the regular ls, but instead of all showing them in columns, kind of all in just a couple short succinct lines, here it shows every directory listed line by line, and it shows you the permissions. It shows you how many files are within a directory, shows you the owner, shows you the group owner, it shows you the file size of the directory, it shows you the timestamp, and then it shows you the name of the directory itself. So it actually shows you quite a bit of information, doesn't it? So the ls-l is pretty useful. And then ls-a, again, all that does is it shows hidden files. Hidden files start with a dot in front of them. Okay. So in this case, I only really have one, is .auto file system check. Okay. Now I can combine them. See, I can do a ls-a and an l together. And what does it do? It lists them long and it lists all of them. See that? So you can actually combine options together. Now some people do it like this, and that's fine. That works too. Did you see what I did? ls-a-l, right? And that works, but it's also quicker just to do ls-al. Okay? So there are other things like that that you'll get used to as well, and how you can handle switches and options and all kinds of other things like that to move pretty quickly through everything. Okay, so this asks the question, right? If you do like an ls of etc, which I actually did earlier, it gives you quite a bit of information, right? Well, what if I wanted to list, just like this says, just the contents of the httpd directory? Well, if I just want to do that, I just do ls etc httpd. See how that works? And it shows me just what's in that directory. Okay, so you should get used to you know, how the ls command works and how you can move around. Then you get some practice here with all of this. So cd space var, you know, moving to that directory ls, cd space. Now, this is a good example. We're currently in the var directory, right? I just did a cd space var. You see this right here, okay? Now, if I want to change into the var www directory, since the www directory is underneath the var, you see this right here? Because it's there, then I have two ways I could get there. I could just do cd space www. See that? And the reason that works is because I didn't put a / in front of this. In other words, if I just do it like this, the directory by itself, then the Linux assumes that that directory is inside of my current directory, which it is. Okay. The other way I could have done it, if I go back to var, is I could do cd space /var www. See how that works? And that's because I'm specifying a hard path or an absolute path to that directory. Now both of those work. Okay. It's much easier to do www, right? But here's where this becomes more important. Instead of being there, let's say you're in this directory, right? Now we're 1, 2, 3, we're 4 directories in, right? And let's say we want to go into the route directory that's within here. Well, I could just type route. Much quicker to get in there, right? Or I could type, if I'm not as familiar with Linux, I could have to do the whole thing. Proc, sys, net, IPv4, route. See, they both go the same place, but it's quicker for me just to type, if I know that the route command right here, I'm sorry, the route directory right here is within this directory, which it is, it's much quicker just to do cd space route. Okay, so they both work. A hard absolute path works, or just the directory itself, as long as that directory is in the current directory you're working in. All right, so that's kind of what this illustrates for you, and I hope that makes sense. Sometimes it takes a while to wrap your head around current working directories. Okay, so pop quiz for you. Which current working directory am I in right now? You can pause this video if you want to think about it. But I'm in the route directory, right? Well, what's the full path of that route directory? Well, pwd tells me proc, sys, net, IPv4, route. That's the full path to it, okay? All right, so then you get some more, you know, kind of exercises to work through, changing directories, all that kind of stuff, okay? There's also some really cool information here about getting through bash. Lots of neat things that'll make your life easier. I'm going to skip by most of those for now. The history command is really cool. Look at this. If I type history, it shows me every command I have run, or at least within a certain time frame. Okay, and look at this, quite a bit. Pretty neat, huh? Where does this come from? Well, where it comes from is, if I look inside my user directory, home west, so let's see, home/west, there we go. If I look within there, doesn't look like there's much there, but if I do an ls-a, I see a hidden file called bash history. See this? So if I open this up, look at this. It shows me all of those commands. See that? Most of them are the same. I guess all of them are the same. So the history command opens that file and tells me all those commands. Now, it brings up the question, why does Linux store all your commands? Here's why. Now, you won't know this, but I'm hitting the up button, or now the down button. Look what Linux does. It has the ability to remember all these old commands I ran. This is great. The reason it's great is because if I ran some big complex command earlier, maybe yesterday or even a minute ago, and I don't want to type the whole darn thing out again, maybe I just need to make a small change to it. Here it is. Like I just need to change that from etcunit.d to etcrc.d, you know, whatever it is. Then that's where the up and down commands to bring back old commands are very, very useful. Now it's dangerous because if a bad guy gets access to your box, one of the first things they might do is go and check in your bash history and see the commands you've ran. Now why would they do that? The reason they would do that is because it would tell them system commands you've run. It might tell them more information about what's on the system, what you've been operating, maybe even some problems you've been having, and it gives them more information about the system itself. Also, bad guys are usually very keen to delete the bash history file and therefore delete out history of commands when they log out of a system so you don't know what they did. So that's where bash history is very useful but also potentially very scary. Alright, let's look. Also we do an ls-f in a directory. Okay, and this will show you anything with an asterisk or an @ sign is a linked file or a binary file. Not real useful. And then now we get to shutdowns. Okay, and this is the last part of this lab. This is a very quick lab. You might not think so from the video lecture, but it is a quick lab. So there's a lot of ways we can shut the system down. Okay, one way is just to use shutdown. And we use the -H to halt it. That works. Another way is power off. Does the same thing. Another way is to initiate run level 0, which will shut it down. There's multiple ways to shut it down. If I just need to restart, I can type in restart. Okay. I can type in init 6. I think a 6 is restart, and that'll restart. So there's lots of things I can do to get out of the system. Okay. I can also just log out. Sorry. Type exit. Okay. And that'll get me kind of out of my working, well, I guess since I'm graphical, I'd have to log out of there too. So let me go ahead and do that. I would do quit and then log out. Okay, so there's multiple ways I can actually get out of the system. And then also for that matter, if I'm in graphics, another way you can shut down is to actually use the button right here and shut down that way. Okay, let me go ahead and switch back to another TTY. And I'm just going to power the system off so you see how this works. I'm going to type power off. And it shuts the machine down. See how this works? And then what you need to do is always remember to wait before you take your hard drive out in lab. Wait until the machine actually shuts down like that. Okay. So this concludes Linux Lab 2. At the end of this lab, you need to be familiar with operating the file system, with getting around from one directory to another directory. You need to be familiar with SSH to where you know how and makes sense to connect from one computer to another. This is a very, very elementary lab. You need to be familiar with looking at the man pages and figuring out information on your own in case you've forgotten something. Really a very, very easy lab, to be quite honest with you. Lab 3 and Lab 4 will get more in depth, and we'll have those published for you later.